Okay, so last week in our experiment, we synthesized crystals of potassium aluminum sulfate dodecahydrate, also known as alum. To begin this process, we synthesized alum from aluminum foil, and however, this creates crystals that are way too small to be seen, and therefore we created a saturated solution of alum and evaporated it slowly so that we would end up with larger, more singular crystals of alum. So I'm going to go over our process and our procedure more in depth right now, and then I'll talk about how the crystal growth has been going. Okay, so first step was dissolving the aluminum foil in the potassium hydroxide, which resulted in aluminum tetrahydroxide ions, hydrogen gas, and potassium ions. We then vacuum filtrated this to separate any insoluble and soluble impurities. Sulfuric acid was then added to create the aluminum hydroxide precipitate, and once that was done, we added more sulfuric hydroxide to neutralize the basic aluminum hydroxide solution. After that, to complete the process of dissolving the solid precipitate, we added more heat, and this resulted in an alum solution. Okay. Once the alum solution was obtained, we slowly added acid to the solution because it's a strong acid, and that's following basic lab safety protocol. So after this was done, it was time for the ice bath part of the procedure. So we would put the solution in an ice bath, and by doing this, it would lower the temperature of the solution, which would lower the solubility of the alum solution, and the alum would precipitate. We then vacuum filtrated this, and by doing this, we isolated the alum precipitate from the rest of the solution. So then, once we were stuck with the solid alum precipitate, we rinsed it to get rid of the impurities and measure the mass. After that, we mixed it with water to make a saturated solution, and here we are. We put it in a vial with a tissue paper on top to allow it to evaporate without letting the solid alum crystals escape. So after about a week lab, we have a few crystals at the bottom of the vial, as you can see. Not a large amount of growth, however, it is some progress. I expect that next week there will be a significant amount more of crystals, but we'll see. And the next question I wanted to discuss was how to make the sodium chloride crystals. So to make the sodium chloride crystals, I would dissolve NaCl, sodium chloride, in heated deionized water, and then pour it into saucers and let it evaporate from there. And it's pretty much the same exact process as would be used for the alum crystals. At the end of the process, the excess water would be evaporated, and we would be left with the solid salt crystals. All right, and another method to grow crystals is it's slow cooling. And to do this, you prepare a nearly saturated solution of your compound at its boiling point or near its boiling point. And so of the solvent, and our solvent would be water. So then after you've done that, you move it to a clean container and cover that container. Then you prepare a heat bath of a similar temperature to the boiling solvent, which would be water, and you put the solution in the heat bath and let it cool slowly. And that's all you need to do. Eventually, you should be left with your crystals. All right, thank you. My sources will be uploaded as well, uploaded on Canvas along with the video. Thank you.